Today, we're diving into a recipe that could literally change the world. And no, it's not about what's for dinner tonight, but about how we'll have dinner at all in the coming decades. We're talking about climate smart rice.
So, let me start with a question that sounds like a riddle. How do you possibly build a plant that can survive being drowned in a flood for weeks and then, just a few months later, survive a crippling drought? And nope, this isn't science fiction. It's the very real challenge facing scientists trying to protect our planet's most important food crop. And believe me, the stakes could not be higher. You see, rice isn't just another food on the shelf. For billions of people, it is the absolute foundation of their diet, their culture, and their livelihood. But right now, that foundation is starting to crack.
I mean, just let that number sink in. More than half of every single person on Earth relies on this one grain. So when rice is in trouble, we're all in trouble. This is especially true in places like southern and southeastern Asia, where our changing climate is creating a perfect storm of problems for farmers.
And here's the really crucial point. It's not just one single threat. Farmers are getting hit by a whole cascade of crises, sometimes all at once. In the very same growing season, their fields can get slammed by a drought, then a flood, all while being attacked by diseases and swarms of pests. It's like fighting a war on 6 fronts at the same time.
So how in the world do you fight a war on that many fronts? Well, you don't build 6 different armies. You build one super soldier. Or in this case, one super rise. Let's get into the mission. Okay, so the objective here was just incredibly ambitious. The plan was to find the specific genes that give rice natural protection against all those different threats. We're talking drought, floods, diseases, pests, and then somehow stack them all together into one single plant. And, here's the kicker, do it without losing the high yields that farmers need to survive. Now, what's so cool is how they did this. This isn't your grandfather's farm, just crossing your fingers and hoping for the best. They used a technique called genomics-assisted breeding. The easiest way to think about it is like a genetic GPS. Scientists can scan a tiny plant's DNA and see these little markers that light up and say, yep, this one's got the gene for drought tolerance. Or hey, over here, this one has the gene for blast resistance. It's incredibly fast, it's super accurate, and it's a total game changer. All right, so let's get into the recipe itself. How do they actually combine all of these different genetic ingredients to cook up a climate-smart crop? It all started with this very complex-looking family tree. Now, I know this looks complicated, but stick with me. At the very top, scientists started with 8 different parent rice varieties. Each one of these parents was a specialist. Maybe one was a champ at surviving drought, another was great at fighting off a disease. By strategically crossing them and funneling them down, they were able to combine all those amazing genetic gifts into a single, powerful lineage at the bottom. Let's break that down even simpler. Step 1, cross those 8 unique parents. Step 2, over 4 seasons, they let the kids interbreed, which basically shuffled the genetic deck and created this huge, diverse gene pool. Step 3, then comes the super high-tech part. They scanned the DNA of thousands of plants, using that genetic GPS to find the ones that hit the jackpot, the ones that inherited the perfect combination of all those protective genes. And finally, step 4, they selected only those absolute superstars to move forward. And here's the part that really blows my mind. The speed. This wasn't some project that took decades. The first crosses were made in 2015. By 2018, less than 5 years later, they had 95 elite stable lines packed with all those protective genes and ready for real-world testing. That's just unbelievably fast. So after all that incredible science in the lab, there's really only one question that matters. Did it actually work out in the field? Well, let's take a look at the harvest.
Wow, I mean, the pictures really do say it all, don't they? In the top photos, you see the new, improved climate-smart rice just thriving. It's green, it's healthy, but look at the bottom row. Under the exact same tough conditions, you see one of the popular older varieties basically struggling to survive. The difference is just night and day. And this right here gets to the heart of the breakthrough. With the old rice, you had a trade-off. Sure, you could get high yields, but the plant was fragile, vulnerable. This new climate-smart rice completely shatters that compromise. You get the high yields and a built-in shield against a whole bunch of climate threats. You don't have to choose anymore.
Now, let's look at the hard numbers, because this is just staggering. Under severe drought, the popular variety produced just 210 kilograms per hectare. But the new line? It cranked out 1,760 kilograms. That is more than an 8-fold increase in yield when conditions are at their absolute worst. For a farmer, that is the difference between total devastation and survival. And get this, it wasn't just about surviving drought. The new lines delivered the whole package. They had high resistance to major diseases, they could fight off key pests, and, this is so important, they had superior grain quality that people actually want to buy and eat.
Okay, so let's zoom out. What does this all mean for the bigger picture? Because this isn't just a cool science story about a better plant. This is a story about how we secure our future food supply.
What this research really does is it gives us a brand new playbook. It proves that you can develop these climate-ready crops in record time, under 5 years. It shows you can successfully stack a whole arsenal of defensive traits into a single plant without making compromises on yield or quality. This is a strategy that could be used for other vital crops all over the world. Don't just take my word for it. The scientists who actually did the work put it best. They confirmed this is one of the very first times anyone has successfully combined so many protective genes into a single high-quality plant. They didn't just tweak a rice plant, they showed us a whole new way forward for creating the crops we'll need to survive. And that leaves us with one final, really powerful question. As our climate gets more and more unpredictable, facing a whole mess of threats at once is going to be the new normal. So could this be it? Is this amazing combination of genetic precision and bold vision the blueprint for the future of our food?